Hey, Stepsters. I'm Lasya.
And I'm Kritika, and we're your trainers from Future Steps.
Today we'll be learning about basic geometry.
Yup, isn't that exciting? Okay, as you see, this guy right here, he's pretty shocked by this topic. And you will be too, not because it's difficult, but because it's really, really easy and very fun. So,
Yeah.
as you might be thinking, like this guy, we are gonna get started. So, right now, you're probably really, really confused. And I get why you might be confused. You might be looking just like this. And don't worry, we get you. So, to erase this confusion of yours, let's get started.
Yes. So you're gonna go with the very, very basic, like from the very starting of basic geometry, right? So like if I give you like a circle like this, like a point. Oops.
Oh, oh my God. Okay, let
Okay,
me take that off real quick.
let me do it. Let me do it besides it. Oh, okay.
There we go.
You just have a point like that, right? What is it called? A point. That's so like, oh my God, isn't that like what we call it? Yes, in geometry too, you call it a point. See, this isn't as bad as you think, guys. Come on, right? I know you're a lot like shouting at me right now, but like it's gonna be easy. We got you. Okay? When you have a point and you have another point, okay, somewhere else, and you like connect them. Right? Okay, that wasn't a good line. Let me just get a good line, guys. Okay, you connect them. That right there is called a line segment. So I know you'll be like, oh, isn't it a line? But no, in geometry, it's called a line segment. So that's when you have like 2 points at like each side and restricting the whole line to be like not infinity and stop at a point. Okay. So what I mean by this is if you have like another point, right? And then you draw a line and then you have an arrow, this means that this side is like not infinity, right? It's just a point and it's defined, like it stops somewhere. But on the other hand, this side, it goes on forever. An arrow means it goes on forever. So in this case, this is called array. So this is when you have like a point on one side and then the other side is infinity. So it's not defined. While as like the line segment, right, it has points on both sides. So that's the difference between a line segment and an array.
Yep. And bef just if you guys are confused, why do you think it's gonna go to infinity? Is because a line in general goes to infinity from both sides. So if you just put a point somewhere and stop that, it's gonna be a ray. And if you put another point, it's gonna become a line segment like Lassie just told you. So now let's try to get into a little more complicated things. So we learned about line segments, and all of that cool stuff. Pretty easy, pretty simple, right? But now, what if I told you geometry isn't only about lines? So that's because we also have something called angles. And angles are actually pretty fun. And why am I telling you this? Is because what an angle is basically if I have something like this right here would be an angle, and an angle is something to a degree that you would use a protractor to measure. So let's just say this is, for example, like 92 degrees, right? That is an angle, okay? So now let's go into types of angles. And I love this because it's really, really simple, like very simple actually. So there are 5 different types of angles. There is an acute angle, which looks like this. And the reason why it's called an acute angle is because the degree is less than 90. So it's less than 90 degrees. That's why it's called an acute angle. Okay? And then we have another angle that is exactly 90, and this is called a right angle. This angle is used pretty often and it's used in a lot of things. So later on in actual geometry, you're going to need right angles and all of these rules we're going to be teaching you. So keep it in mind. And then we have an obtuse angle. Now, what is an obtuse angle? Any guesses? Okay.
So an obtuse angle is going to be like this way. Okay? So what does an obtuse angle mean? It means it's more than a 90 degrees, but it's less than 180 degrees. So just know that an acute angle is like below 90 degrees, but it's more than 0 degrees. Okay. And
Yeah.
on the other hand, an obtuse angle is more than 90 degrees, but it's less than 180.
Mm-hmm. And then that was just 3 of our 5 types. And the other 2 types are probably, I wouldn't say the simplest, but the next type is the simplest because look at this. What is that? A straight line, right? What do you think this is? This is a 180 degrees, and every angle that's 180 is basically just a straight line. That is why this angle is called a straight angle. Very simple, right? Because it's a straight line, that's why it's a straight angle. Now, the next angle, which a lot of people get confused on, is a reflex angle, which is annoying because look, we have an angle that looks like this, right? And you'd probably look at this and you'd go, well, this side of the angle was an acute or an obtuse angle. It looks more like an obtuse, right? And then the outside angle is what we call a reflex angle. Why? Because it's more than 180, but then again, it's less than 360. And 360 is basically a whole circle, right? So this is called a reflex angle. Okay? Now those were our main 5 types of angles that we're learning today. But there are definitely more weird looking things, but this is what the base starts from, and this is what you need to know. And I know you're mentally throwing deaths at me, and I truly apologize for that. But the thing about this that is really fun is that if you look at these angles, and okay, so let's just make it a little fun, right? Something like a straight angle is really simple to remember, and then let's go to reflex angle. Now for reflex angle, the way I would remember this is think about an overstretched angle. So it's really big. It's something really unusual. That's why it's a reflex, because it's over what you would think of it to be. And I know that doesn't make it any much simpler, but it's a lot simpler than you think it is. And remembering these angles are honestly not that bad, especially with straight and right, because they're pretty simple, right? And for right, you could remember it as an L. So think of it as L for left, but think of the opposite. And that will be useful because later in the future, a lot of things you're gonna have to think about the opposite of what it looks like, which we won't go more in depth because that is for when you get older. Oh, also, there is another type of angle. I talked about it, but I didn't write it out, so let me just write it out real quick. So another angle is just that. And that's a circle. And I know you're telling me that's a circle. And it is a circle. Because, like I told you, a circle has an angle of 360 degrees. And anything that's an angle of 360 degrees is most likely a circle. Yep. So remember that there are
Yep.
5 main types, and then the last one is basically just an add-on kind of thing that a lot of people already know.
Yeah. And now we're gonna look at, okay, I know this is a lot, but we're almost getting to the end. After this, Kritika is gonna explain like shapes and their angles, and we'll be done. So this is about how like you can identify patterns between like parallel lines or like lines that intersect. So what I mean by this is, you know what lines are, right? Like line segments, and you know what parallel lines are? Maybe not, right? Let me explain. So parallel lines are just like two lines that never meet each other. So these lines, they will go on forever, but they can never meet each other. What I mean by that is, let's say there's a line like that, and there's another line like that. So like this line will soon meet this line because they will intersect. So what I mean by that, they have a point together, right? But these two lines, they'll always continue that way, right? They have no place they meet like these do. So that's what I mean by that there are parallel lines. So when you have like two parallel lines, like I have here, and you have like another line connecting them like that, right? The angle here and the angle here are known to be the same. So if you have the same setup, like it kind of looks like a Z, right? It looks exactly like a Z. Or it can also look like an N, right? Or it can look like an downward N, right? But all you need to know is this angle and this angle, or this angle, this angle, or this angle, and this angle are always going to be the same. So if this is 30, that's going to be 32. Okay? And so on. So if this is 40, for example, that's going to be 42.
Mm-hmm.
Okay? And these are called alternating angles. What are they called? Alternating. Sorry, guys, I'm taking so long to type it in, but like, just know that they have a name for them, right? We have names for everything. So these are called alternating angles. Now let's look at other types of angles. So when we have like two lines, again, parallel lines, like we talked before, they never meet each other, okay? And then we have like another line going straight to them, right? Connecting those two kind of thing. And you have like these angles here and here. So these angles are also going to be the same. So this, you can remember it as like, oh, this looks like an F, right? Or you can say it looks like a downwards like F. Or you can say it looks like a C. Sometimes they just give, oh, wait, it cannot be a C. It can only be a F. Or it can be like an opposite facing F, but always know that this angle and this angle would be the same in any case. So just like before, if this is 30, that would be 30. If this is 40 or any other number, the other one would be the same number. And let me just divide that. These are called corresponding angles. Yep. And then we have like a little more to learn. We're almost there. Okay. The next ones are if you have like two lines, again, you can say parallel lines, right? They're parallel lines and they're connected. Okay. It can be an F or it can be like a C, doesn't matter. They're just connected. Two parallel lines are connected, or it can be like an eye, doesn't matter. They're just connected. But what you need to know is this angle that are inside of that shape, right? Like inside of that shape are these two angles, are these two angles. Okay, when I put like two things, okay, sometimes you'll see this, okay? Not now, but later on when you like go to like higher grades, you'll see like you have two lines and sometimes you have like three lines or something. That just means that this angle is not the same as this kind of thing. Okay, that's all you need to know about that for now. And now what all of this means is these two angles, they need to add up to 180 degrees. So same for all of these, okay? All the three of these, they need to add up to 180 degrees. And these are known as congruent or co-interior angles. So co-interior angles. Okay, that's great, right? And we have like one more, right? And then we're gonna be done with angles. Yes. So wait, but critic has more, right? Yeah. But like those are easy. You're gonna get the hang of it. Don't worry.
Yeah.
And the last one is vertical angle. So what I mean by it, we're not dealing with parallel lines anymore. Yes. Now we're talking about intersecting lines. I told you before, they have a point together where they meet, right? And what this vertical line theorem says is that basically this angle and this angle or this angle and then this angle are the same. So this one and this one, they are the same. Okay. And then this one and this one, they are the same. So that's basically what the vertical angle theorem says. And if you remember what we learned before about straight lines, doesn't this look like straight lines to you guys? Yes, it does. It looks like two straight lines connecting to each other. So another thing you could say, let me just change my colors real quick. Another thing you could say is this angle adds up to 180 degrees. And this angle adds up to 180 degrees. This angle adds up to 180 degrees. This angle adds up to 180 degrees. And all of this adds up to 360 degrees. See how everything connects? Like everything is connected in geometry. So knowing everything is really important.
Mm-hmm. I mean, everything in math is connected generally.
That's true.
So remember everything in math. And just for background information, just some extra information, this point where the two lines meet is known as the point of intersection, which I'm just telling you because that comes up sometimes. Intersection. There you go. And now moving on to some very nice shapes. Okay, so we talked about all these properties and all these rules and these theorems, and you're probably wondering, well, is that all for today? Well, I know you guys are throwing dust at me again, but there is just one small part left, okay? So let's get through it real quick. Now, we talked about angles and we talked about rules with lines. Now we're going to talk about how this applies in shapes. So let's take a triangle for example. Okay, we have a triangle. Okay, first off, when I write down triangle, notice something. It's made of two words, tri and angle, right? And we know angles are angles, and we know that tri means three. So a triangle consists of three angles, okay? So if I make a triangle, we have one, two, and three angles. And notice how I made them all the same angle? This type of a triangle is called an equilateral triangle. Let me try writing that out real quick. So this, where all angles are equal, is going to be called an equilateral triangle. Okay? And the reason why I'm telling you this is because this shows up quite a lot. Now, you're probably wondering, okay, well, all sides are equal, right? So, fun fact, since all sides are equal and they're and a triangle, in a triangle, all angles should add up to 180. So if this is angle 1, this is angle 2, and this is angle 3, angle 1 plus angle 2 plus angle 3 should all equal 180 degrees. So since 1, 2, and 3 are the same angle, that means that all of these angles are 60s. So this angle is 60 degrees, this angle is 60 degrees, and this angle is also 60 degrees. That's the fun thing about equilateral triangles that I really love. Now, next up, we have another type of triangle, and I know you're once again throwing desks at me because you're like, well, a triangle is a triangle. Why do we have different types of triangles? Well, just like any other shape, there are always more than one. So let's look at our second type of triangle. This is called an isosceles triangle. And I know you're probably wondering, what do you mean by isosceles? What I mean by this is that it has two angles that are equal to each other, so these two angles are equal, and then this angle is not equal to them. So if I draw a line down the middle, and I know these two angles, and I know this angle is equal to this angle, right? Then we know that this is 90 and this is 90, right? Then that means the angle on this side and the angle on this side would also be equal. And guess what? There's another type. So there are three types of main triangles, but then there's another triangle that people don't usually talk about when they're talking about triangles, because there are a lot of laws and rules related to it, but it's also a really important triangle. So we talked about isosceles. Our isosceles has two angles that are the same and one that is different, right? And then there's another triangle which looks somewhat, okay, that was not a straight line, which looks somewhat like this. Okay, and you look at it, the thing about this is, this angle does not equal to this angle, which does not equal to this angle. So all three angles are different. And this type of a triangle is called a scalene triangle. And it looks pretty simple, pretty nice, right? Now there's a fourth type of triangle, which I didn't quite mention earlier, but I would like to mention. It's called, this is our right angle, right? Because remember, if I scroll back up, in our angle section, we talked about our right angle, which was a 90 degree, okay? So that means this thing is our right angle, which is 90 degrees, right? What if I connect this end to the other end? Does that not look like a triangle? Yes, it does. So this is called a right triangle. Very simple, right angle, right triangle. Very nice. And the special thing about this is it's a right triangle because one of its angles is a 90. And then there are two types of right triangles which don't really have names, but it's just they could they're two types that are used later on. So there's one where there is a 90-degree angle and then these two sides are equal, and those sides are both 45 degrees. Because remember, all angles should add up to 180, right? And then the second type is this one is used pretty much, which you will need in the future, and I'm just giving you more information so that later on you wouldn't have to struggle with this and you will already know it. So this type of right triangle is basically this angle and this angle is not equal, and that's a lot of different types of triangles. But the one of these type of triangles I do want to mention is the one where there's a 90-degree angle, then there's a 30-degree angle, and then there's a 60-degree angle. And this is your 30, 60, 90 triangle, which you will need later. So 30, 60, 90. That's how everyone writes it. I'm only telling you this because if you remember it now, it'll be easier for you in the future. And I would say it's a really nice thing to remember things early on. So, but if you don't want to remember it, just remember that right triangles are triangles that have a 90-degree angle. Okay? And then we talked about triangles and angles and what goes on with it. Now there's a different shape, which we did learn about earlier in our shapes video if you did watch that. If not, you probably learned about it in school. So this is called a quadrilateral. Quadrilateral, right? And this is basically quadri means four, and lateral is, well, let me show you. So quadrilateral, for example, let's take a square, right? A quadrilateral is something that has four sides, and this thing has four sides, right? And guess what? It also has four angles. And notice how it's called a quadrilateral and not a quadriangle like a triangle? That is because it has four lines that make up a quadrilateral. So it has four lines and four angles. Okay? And in a square, every one of these angles is equal. And just so you know, every single one, so let's call this angle A, angle B, angle C, and angle D. Okay? So the rule about quadrilaterals is angle A plus angle B plus angle C plus angle D is going to equal 360 degrees. Just like how in triangles every angle adds up to 180, in quadrilaterals every angle adds up to 360. And the only reason I'm telling you this is because it can be pretty useful. Because if I give you the value for angle B and I give you the value for angle, so you have the value for angle B and then you have the value for C and you have the value for D. Like, because you have the value of these angles, you can just use this formula that I told you where all angles should equal 360 to find the value of angle A. Pretty simple, right? And that is technically all you need to know about quadrilaterals, and everything else you do know. And quadrilaterals don't have to be squares. They can be rectangles, they can be trapezoids, they can be all these other types of shapes. And some of these would also have parallel lines in them. So they could have a, you could also use those parallel line theorems and vertical angle theorems and all of that. And if you want to see an example, let me show you. So let's say we have two parallel lines, right? And then they're connected like this. That's a shape, that's a quadrilateral. What you know about this is that this, and this should all add up to 360. Now, if I draw a line across, you're gonna know that, let me change my color so it's easier for you to see. You're gonna know that this angle right here and this angle over here are gonna be equal. And that way you can have many questions, but you're probably not gonna have those just yet. But it's always good to know things for the future. So now that we know everything, let's quickly go ahead and recap. Because basic geometry did include a lot of things. So recap is a point, connected to another point is a line segment. A line is basically both sides going to infinity. A ray is one point and the other side going to infinity. We have 6 types of angles: acute, right, obtuse, straight, reflex, and then our full rotation or complete angle, which I didn't label here, but I will label it now. Oh yeah, look, our confused emoji. Remember this guy? I'm pretty sure you don't feel like him anymore. So let's cross him out, because he's out of our story for tonight. So this is our complete angle. That's our acute, right, obtuse, straight, and reflex. And then we have alternating angles, which are equal in parallel lines. So this is all just parallel line theorem. And then we have corresponding angles, which are also equal. And then we have co-interior, interior, corresponding, whatever one you guys prefer, which are also equal. Then we have vertical angle theorem, where if they're across from each other, they're equal. And then we know this is called a point of intersection in two lines crossing each other. They are not parallel, because if they're parallel, they won't cross each other, like Lassia mentioned earlier. And then we know triangles. We have 4 different types of triangles. We have equilateral, isosceles, scalene, and right. And then there are 2 types of main right triangles. And then a triangle, every angle inside a triangle should add up to 180. And then we have a quadrilateral, 4 sides, 4 angles. All angles add up to 360. And then this can also include a lot of questions that go back to the other things we learned today.
Yep. And that's all for today, guys. We're done with basic geo. Yay! Yeah.
Yep. And if you have any comments, concerns, any questions, comment down below. And you could also personally email us if you'd like. Our email will be given at the end of the video. And if you don't like emailing, just comment down below, because that's a good option. We do look at our comments and we will reply. If you want us to make a video on something that you didn't understand or that we didn't make a video of yet, you can comment down below and we will look at your request and make a video on it. Or you could just email us.
Yeah. And make sure to practice problems about this and keep revising the work again and again to make sure it lasts in your memory for a very long time.
Mm-hmm. And every time you feel frustrated, do remember a Mr. Let's call him Bob. Do remember Bob. He is a fun guy and he's always confused. At least you know you're less confused than him. So, thank you so much for watching. This was our entire video on basic geometry, and we'll hope to see you in our next video. Goodbye.
Bye, Stepsters!